Let's continue on with area. We've got area of parallelograms and rhombi. Did you know you can call them rhombi or rhombuses? Both of those are correct. A little fun fact for the day. Anyway, let's talk about the area of a parallelogram. Check it out. It's basically a rectangle that has been pushed a little bit. Okay, so since it looks like a rectangle that's been pushed a little bit, the area is base times height. And I'm going to write in red because you don't have to write this down, but if I combined that triangle with this triangle, just pretend I bring it over here like this. Now do you see that it is a rectangle if I add this area of this guy over there? Okay, so that's why it's base times height. Just wanted to kind of give you a background there. So let's do some examples. And you notice that the base and the height are perpendicular to each other right there. So going over here to number 1, they're trying to really confuse you here because there's a number there you do not need. And remember that the base and the height are perpendicular to each other. So this must be my height and this must be my base, and this right here must be something that they are using to confuse you. So if the area is the base times the height, then the area here would be B, which is 9, times H, which is 8. So our area then would be 72, and did you remember your units? Centimeters squared. There we go. I'm going to go ahead and have you do number 2 for class. And why don't you go ahead and do number 3 for class also. Let's see if you can get these two. Now number 2 is going to be a little trickier than number 3, but remember what I said about base and height and how they have to be perpendicular, and I think you can handle it. So we'll do 2 and 3 in class. So go ahead and pause it now, do them, or do them when you're done watching the whole video, but do have them done for class. Let's go on to number 4. The area of a parallelogram is 96 yards square. So this is area. If the base of the parallelogram is 6, so this is the base, what is the height of the parallelogram? Well, first let's write down the formula for the area of a parallelogram. And that is area equals base times height. Our area is 96, and then they told us our base is 6, so this would be 6h. And when I divide both sides by 6, because that's the inverse of multiplying, I get 16 equals the height. Well, what is it? 16 cats, 16 dogs, 16 rainbows? 16 yards. So the height is 16 yards. Don't square it. Squaring is area. You don't want to square it here. And then I am going to ask you to go ahead and bust out number 5 there and bring it to class. So this whole front here, all about parallelograms, everything's base times height. Hopefully not too bad so far. So let's keep it going here. Talking about rhombus. Rhombi, rhombuses, singular form is rhombus. Doesn't this look crazy? Looks real crazy, right? So a diagonal is this, right here in a rhombus. And that will be diagonal 1. We'll call that diagonal 1. And then this is diagonal 2, okay? So if I do diagonal 1 times diagonal 2, and I divide it by 2, I have the area of a rhombus. Since a rhombus is also a type of parallelogram, you can also use base times height. So I want you to keep that in mind when you're doing your problems. And if you run into a situation where the rhombus does not have information for its diagonals, you probably want to do base times height. Okay? So let's go ahead and check out the problems we have below. Number 6. All right, so definitely looks like we have some information for the diagonals. So first we have this. So that means diagonal 1 is going to be 7 plus 7, which is 14. And then we have this diagonal right here. I'll highlight it in red. And this diagonal here would be 9 plus 9, which is 18. All right, so we know that the formula is half times diagonal 1 times diagonal 2. So then our area is going to equal half times, well, diagonal 1 is 14, times diagonal 2, which is 18. And if we go ahead and type that up into our calculator, multiply it out, we'll get that our area is 126 meters squared because it is area, okay? I'm going to have you go ahead and do number 7. Bring number 7 to class. Done and completed. I have faith in you that you'll be able to figure this one out, even though it looks a little bit different than number 6. And let's go ahead and talk about number 8. So we mosey on over to number 8 and we see, hey, we do not know anything about these diagonals. They have not told us anything at all. So if this happens to you, just remember that a rhombus is also a type of parallelogram. So this would be your base. Now what's the height? Think perpendicular. That's your height, okay? All these other little guys here are just the lengths of the sides. So we have area equals base times height because a rhombus is a type of parallelogram. The base here is 8, so area equals 8 times, and the height here is 7, so 8 times 7. And when you multiply those together on your calculator, you get that the area equals 56 feet squared. Boom, done with that one. All right, so bring number 7 to class. You can pause it now and do it. You can do it at the end of the video. Whatever floats your boat, just have it done when you see me in class. Let's go on to number 9. The area of a rhombus is 120 kilometers squared. So I'm going to label that A. If one diagonal of the rhombus is 24, you know what? Since that's one diagonal, I'm going to label it diagonal 1. Find the length of the other diagonal. Okay, so our area equals half times diagonal 1 times diagonal 2. Well, we know our area. They told us it's 120. So 120 equals half times, okay, diagonal 1 they've also told us, which is 24. So times 24, and we don't know diagonal 2. That's what we're seeking out. That's what we're trying to find. So if we do 0.5 times 24, we get 120 equals 12 times diagonal 2. 12 times diagonal 2, inverse, division, we're going to get 10. So what is that? 10 what? Puppies? Happy faces? Killer clowns? No, kilometers, all right? So diagonal 2 is 10 kilometers. All right, well, we're done with those. Let's move along. Woo! Number 10, looking real sharp. So find the area. You know that's a complex polygon, right? What two shapes are there? Well, that's a triangle and that's a rhombus. We have to think back on when we learned about rhombuses. And when we learned about rhombuses in the past, we learned that right here they form a 90-degree angle. And we're going to have to do something with that because I want you to look at this triangle. It's half times base times height, but what's the height? You don't know. Don't try to make up some numbers for it. You don't know what this height is. So what we're going to have to do is look at this triangle right here, and we're going to have to use a super special theorem called the Pythagorean theorem to find out what this guy right here is. So I'm going to kind of redraw this triangle right here as best as I can. So this is 8 and that's 15, and here is your right angle. So Pythagorean theorem, the legs are what's perpendicular and the hypotenuse is the one that is not perpendicular. So that's our C. So we know that a squared plus b squared equals c squared. Well, you can call 8a if you want, and you can call 15b if you want. So then we have 8 squared plus 15 squared equals c squared. And we use our calculator and we find out that 8 squared is 64. And we use our calculator and we find out that 15 squared is 225. So that all equals c squared. And I hope that you write smaller than me because I definitely am going off the page here. So 64 plus 225 is 289. That equals c squared. How do you get rid of a square? Well, you square root it. So if we square root both sides, we are at this point right here. And then the square root of 289, the calculator, is 17. So we found out that this right here is 17. So now we can finally start working on the area. So can you even believe that? We have not even started working on the area yet because we had to go do a little investigation to find out what that height is for that triangle. So I just highlighted that triangle in green so you can see what's really going on. So our triangle is going to be half times base times height. All right, so A equals 0.5. What's our base? 6. What's our height? 17. And then we're going to go ahead and type all of that into the calculator, and when we type all that in, we end up getting 51. All right, so there's the area of our triangle. Then we have this slick little guy right here, this rhombus. How do I know it's rhombus? All the sides are congruent. Yep, that's right. All the sides are congruent. So that's how I know it's a rhombus. And to me, I think we know enough about the diagonals. It looks like diagonal 1 right here would be 15 plus 15, which is 30. And it looks like diagonal 2 right here would be 8 plus 8, which is 16. And then I know that the area of a rhombus is 0.5 times diagonal 1 times diagonal 2. Okay, well then the area of a rhombus is 0.5 times 30 times 16. And when you type all that into the calculator, you get 240. It's a whopping number there, right? So 240. And then what you're going to do is you're going to add these together, because in a complex polygon we've got multiple shapes that we have to add together. And when we go ahead and we add those together, we get 291. Now what is it? 291 cats, Starbucks drinks that Mrs. Storvik really likes, and you want to buy her probably because you really like her as a teacher and you want to reward her. Nope, none of those. They don't even give us the units, right? So it's just going to be 291 units squared. And you're just going to leave it like that. All right, well, that about wraps it up here for the rhombi and for your beautiful parallelogram. So I will see you in class. Make sure that you have all those problems I asked you to do done, and I will see you then. Goodbye.